We're on lesson 9-9, guys, which is on adding mixed numbers. And we're going to do it using what's called the standard algorithm, or the standard way, the regular way that people do it. So no models, just putting them together and adding like we do with normal numbers. So we have this first part. Brenda adds 1 1/8 cups of peat moss to her soil in the problem on the previous page. How much soil does Brenda have now? Well, if you remember on the previous page, she had 4 cups and 2/8, and now we're going to add 1 1/8. So what would that be? Well, remember when we're adding fractions and whole numbers, which is called a mixed number, when we add mixed numbers together, we add our fractions first, and then we add the whole numbers. So let's see, 2/8 plus 1/8, well that's 3/8, and then we add those whole numbers. 1 plus 5, or 1 plus 4 is 5. So our answer is 5 3/8 of a cup. Remember, add your fractions together, then you add those whole numbers together. So number 2, use another strategy to find the sum. Well, here we added the whole numbers and the fractions, but we can make it into that improper fraction. So what do we have? Well, we multiply first. So 4 times 8 is 32. And then we add. So 32 plus 2 is 34. Then we do that same thing here. Remember, we multiply. And then we add. 1 times 8 is 8. Plus 1 is 9. So now we can add these fractions together. So we have 43 over 8. And I know 8 can go into 43 5 times. There's 5 holes we can pull out. 43 minus 40, because remember I'm pulling 5 groups of 8 out, I'd have 3 left over, 3/8. And notice how my answer here is the exact same thing as my answer from number 1. Let's head on to number 3 now. So remember, we add our fractions first. 7/8 plus 2/8. 7 plus 2 is 9 over 8. And then we add those whole numbers, and we get 2. Now notice, we have what's called that improper fraction. So we have to take a whole out. So we have 1 whole. Whoa, that went crazy. We have 1 whole, 8/8, and then we're left with 1/8 left over. So this is 1 whole plus 2 wholes. So we have 3 wholes and 1/8. Now off to number 4. So remember, we add those fractions first. 4 tenths plus 5 tenths. 4 plus 5 is 9 over 10. And then we add the whole numbers. 2 plus 5 is 7. Our answer is 7 9/10. Number 5, add our fractions first. 2/3 plus 2/3, that is equal to 4/3. And then we add those whole numbers. 4 plus 1 is 5. Now notice we do have a whole hidden in here, so we can break that up into 3/3 and 1/3 because this is a whole. So we have 1 whole and 5 holes. So together we have 6 holes with that 1/3 left over. Number 6, we add our fractions first. So 5 plus 11 is 16 over 12. And then we add our whole numbers. So we add 4 plus 5 is 10. Notice again, I have an improper fraction. So I have a whole number hidden in there. So I'm going to pull that whole out. So I'm going to take 12 12ths out and regroup it as 1. And I took 12 12ths away from 16 12ths. So that's 16 minus 4, or 16 minus 12 is 4. Remember our shortcut. If that top number is bigger, we can just subtract. Number 7, we add our fractions first. 1/3 plus 1/3 is 2/3. And then we add those whole numbers. 2 plus 2 is 4. So our answer is 4 2/3. Number 8, remember we add our fractions first. So 9 plus 5 is 14 over 12. And then we add the whole numbers. 8 plus 5 is 13. Notice this is an improper fraction. That top number is bigger. So I need to take out some wholes. So remember, I can subtract 14 minus 12. That tells me there's one hole hidden in there. So I have 13 holes, and I'm getting one more hole. So I have 14 holes, and then I have 2 left over. Because remember, 14 minus 12 is equal to 2. So now let's head to number 9. So number 9 says, for number 9 and 22, find each sum by adding mixed numbers or by adding equivalent fractions. So I'm going to add my mixed numbers just because I think that one's a little easier, unless it tells me specifically. So let's look at number 9. It says add the fractions, okay? So we add our fractions. 3 plus 4 is 7, 6. Add our whole numbers. 1 plus 2 is 3. And then what do? Write the mixed number, or write the fraction as a mixed number. So, what does that tell us? Well, I have a hole in here because that's 6, 6 plus 1 6. So I need to take that one hole and I add it to that 3. So I have 4 holes and 1 6 left over. Number 10. Oh, this one's doing it a little different. So this is our other way. It says write the mixed number as fractions. So remember, I multiply. 2 times 4 is 8. And then I add. 8 plus 1 is 9. So I have 9 eighths. And the same thing here. I multiply. 3 times 4 is 12. And then I add. 12 plus 2 is 14 over 8. So now I can add those up. 9 plus 14 is 23. And I made a mistake. I'm sorry, guys. This isn't 8. This is a 4. And I know it's a 4 because of right here. I did not read my directions. Read my problem carefully. So 23 fourths. Now, how many times does 4 go into 23? It goes in 5 times. Then what do I have left? Well, I'm taking away 20 because that's 5 groups of 4. So I'm left with 3 fourths. Now for number 11. 2 and 5 6 plus 5 and 4 6. It's not telling us which way, so I'm just going to add my fractions first. So I have 5 plus 4 is 9 6. 2 plus 5 is 7. And then remember, I can break this improper fraction up into a whole and 3 6. So this is going to be 8 and 3 6 because I'm taking that one whole out. Over here, let's add our fractions up. So 7 plus 9 is 16 over 10. 11 plus 10 is 21. And now, what can I do? Well, I can break this 16 tenths up into 10 tenths and 6 tenths, which means this is a whole that I can add over here. So I have 22 wholes and 6 tenths left over. Number 13 now. 7 eighths plus 5 eighths is equal to 12 eighths. And I add those whole numbers. 9 plus 7 is 16. Notice again, I can make a whole out of this. So that's 8 eighths plus 4 eighths. And this whole I'm regrouping over here. So 1 whole plus 16 holes is 17 holes and 4 eighths. Number 14, 7 eighths plus 1 eighth. Well, 7 plus 1 is 8. Denominator stays the same. 5 plus 8 is 13. And notice this one is a little different because this is a whole already. And then there's no fractions left over. So I have 13 holes in one hole, which is 14 holes. Now, number 15. We add our fractions together. So I have 6 tenths, and then we add our whole numbers, which is 10 holes. So 10 and 6 tenths. Number 16, let's add those fractions first. 9 plus 7 is what? That's 16 over 12. And then we add the whole numbers. 9 plus 4 is 13. So we have 13 and 16 twelfths. Now what do we do with that information? Well, I have a whole. I can break 16 twelfths up into 12 twelfths and 4 twelfths. So there's my one whole. So I have 13 holes and this one hole. So I have 14 holes total. And I have this guy left over, 4 twelfths. So 14 and 4 twelfths. Number 17. We add our fractions first. Notice though, there's no other fractions. So my fraction is just going to be 1/8. And then we can add our whole numbers. 8 plus 5 is, or 3 plus 8 is, 3 plus 5 is 8. Number 18 now. So we add our fractions first. So 3 plus 3 is 6 over 4. And now we add our whole numbers. 7 plus 8 is 15. Notice again, 6/4 is an improper fraction, so I can take a whole out. I can take 4/4 out, and I can take out another 2/4. So this is 1 whole plus 15 wholes. So we have 16 wholes. Then I have just 2/4 left over. So 16 and 2/4. Number 19, we add those fractions again. 4 plus 3 is 7 over 5. Remember, we always add the fractions first. And then we add our whole numbers. 2 plus 7 is 9. Now what do we notice? 5/7 is improper, so I need to take out a whole. So that can be 5/5 and 2/5. So there's my 1 whole. I have 1 whole plus 9 wholes. So I have 10 wholes, and then I have 2/5 left over. So my final answer is 10 and 2/5. Number 20, add our fractions together. So we have 2 plus 5 is 7/6. Then we add those whole numbers. 8 plus 3 is 11. Notice again, that is an improper fraction. So I need to rewrite 7/6 as 6/6 and 1/6. So I'm going to take this 1 whole and regroup it. I have 11 wholes, and I'm getting 1 new one. So I have 12 wholes, and then I have 1/6 left over. So 12 and 1/6. The last 2 on this page. Here we add our fractions first. 7 plus 10 is 17/12. And then we add 2 plus 1 is 3. Notice again though, an improper fraction. That top number is bigger than the bottom number. The numerator is bigger than the denominator. So I'm going to pull out a whole, 12/12. And I add that 12/12 to my 3 wholes. So 3 wholes plus 1 whole is 4 wholes. And how much do I have left out? Over. Well, I had 17, and I pulled out 12/12. So that tells me, dun dun. There we go. So that tells me what? 17 take away 12 is 5. So I have 5/12 left over. And now number 22. Remember, just like all of the other problems, we add our fractions first. 6 plus 3 is 9 over 8. And then we add our whole numbers. 9 plus 3 is 12. Again, I see an improper fraction where that numerator is bigger than the denominator. So I'm going to pull out a whole. And then I have 1/8 left over. So 1 whole plus 12 equals 13 wholes. And then that 1/8 left over as well. Okay, on to our word problems for the back. It says, use the map to the right. So let me just clear off my stray marks. And now we're good to go. Find the distance from the start of the trail to the end of the trail. So here's my start. Here's my end. So we have 3 and 7/8. And we need to add 2 and 7/8. So what does that look like? Well, again, I add my fractions first. 7 plus 7 is 14 over 8. And then I add my whole numbers. 2 plus 3 is 6. Now, that's not our answer because it's an improper fraction. So, oops, and guess what? I was getting ready to write the answer. 2 plus 3, I had already regrouped. 2 plus 3 is what? Is 5. So I need to regroup because I can pull a whole out. I can pull 8/8 out of 14/8. And then I'm left with 6/8. So this 1 whole I regroup. It's going to become a 6 wholes with 6/8 left over. Now for B, it says Linda walked from the start of the trail to the bird lookout and back. Did Linda walk more or less than if she had walked from the start to the end? Well, start to end is 6 and 6/8. We just figured that out. So now it's saying she did what? It's saying that she went from the start to the bird lookout. So she went 3 and 7/8. And then it says she did what? It says she came back. So she came back this way. So she walked another 3 and 7/8. So what would that be? Well, it's an addition problem, isn't it? So let's add our fractions together. 7 plus 7 is 14 over 8. 3 plus 3 is 6. Regroup because we have a hole hidden in there. So I'm taking 8/8 out, giving them to that 6 holes. 1 hole plus 6 holes is 7 holes, and 6/8. So now what's more? Well, 7 and 6/8 is larger than 6 and 6/8. So what'd she do? She walked more. And if you think about it, we honestly didn't have to do math, because think about it. She walked 3 and 7/8 here, and then on the way back, she walked another 3 and 7/8. But if she kept going forward, she'd only walk 2 and 7/8. So yeah, obviously coming back is going to be longer because it saves a longer distance. It's a bigger number. Now 24. Joe biked 1 and 9/12 mile from home to the lake, then went some miles around the lake, and then back home. Joe biked a total of 4 and 9/12 of a mile. How many miles did Joe bike around the lake? Well, I'm really confused, so I'm going to draw a picture for us. I'm going to draw my tape diagram. So here is the total amount that he biked. And the total amount that he biked was what? Total amount that he biked was 4 and 9/12 of a mile. And it tells me that he biked 1 and 9/12 mile from home to the lake. So he biked this part, 1 and 9/12. That's from home to the lake. Then he biked around the lake, I don't know how much. And then he biked from the lake back home, which makes sense. That's also going to be 1 and 9/12. So we have to figure out that missing part. So, So what I'm thinking that maybe we should try doing is adding these two together, seeing what we have, and then subtracting them, taking them away to see what we're left with. So let's give that a try. So we have 1 and 9/12 plus 1 and 9/12 gives us 18/12 and 2 holes, which I can regroup that. I can take a hole out. And when I take that hole out, that's going to be 12/12 and 6/12. So that's going to give me 3 holes. So there and back, he biked 3 miles and 6/12, 3.5. Now, what do we know about this missing part? Well, we know that 3 and 6/12 plus this mystery part needs to equal 4 and 9/12. So I'm getting a little crowded here, so let me zoom in. Needs to equal 4 and 9/12. So what would that be? Well, let's add our fractions first. 6 plus what equals 9? Well, 6 plus 3 equals 9. And then 3 plus what equals 4? Well, 1. So our answer is 1 and 3/12. We could have also subtracted 4 and 9/12 minus 3 and 6/12, and we've got that same thing also. Now, let's head to number 25. The bus took 4 and 3/5 an hour to get from the station to Portland, and 3 and 4/5 an hour to get from Portland to Seattle. How long did the bus take to get from the station to Seattle? So, let's start here. We have, whoa, that's a big one. We have the bus going from the station to Portland. So from the station to Portland is how long? Station to Portland is 4 and 3/5. And then from Portland to Seattle is what? It's 3 and 4/5. So what do we need to do to find out that total time? We have to add them together, don't we? So let's do that. 4 and 3/5 plus 3 and 4/5. Remember, we always add those fractions first. 3 plus 4 is 7 over 5. 4 plus 3 is 7. I have a whole number hidden here, 5/5 and 2/5. So I take that whole number and I add it to that 7. 7 holes plus 1 hole is equal to 8 holes. And I'm left with this 2/5 right here. So our answer is 8 and 2/5 of an hour. Number 26, we only have 3 more left. A male Parsons chameleon can be up to 23 and 3/4 of an inches long. It can extend its tongue up to 35 and 1/4 of an inch. What are 3 possible lengths for the chameleon when its tongue is extended? So notice it's not saying that the chameleon's tongue and body is 35 and 1/4. It's saying his tongue can go 35 1/4 of an inch. Its tongue can actually be bigger than its body. So what are some possible ways that we can measure how long it'd be, including his tongue? Well, maybe he takes his tongue and he just sticks it out very little. He sticks out 1/4 of an inch. So his body and his tongue could be 24 inches long. We could even make it longer. We could say he sticks his tongue out for 20 inches because it just can't be more than 35. So 20 plus 23 3/4 would be 43 3/4 of an inch. And our last one, let's just say he stuck it out for 30 inches. Well, 23 3/4 plus 30 is 53 3/4 of an inch. So really, there's plenty of answers that we could have for this one. Now we have just two more. It's our multiple choices. So number 27 says, how long can an extension cord can Julie make by attaching a 22 3/8 foot and a 26 6/8 foot together? Select all the possible sums.
What if they're having an important meeting in here?
They're not having an